Okay, so let's talk compound inequalities. I'm going to try to keep this video as short as possible because I think typically your attention span can't take more than one or two examples and really stay focused. So let's just look at the big picture here. We'll look at an example or two, and that should be enough for you to be able to try your homework and take advantage of some of the other resources that are available to you. Okay, so let's just start with an example. What is a compound inequality? Basically, it's an inequality that uses the word and or. So if we start with an example, let's just take 2x minus 2 is less than or equal to 6, and 3x plus 6 is greater than negative 3. Okay, so what does the and mean? We could look at a very similar example and do nothing but change the and to or, and this is a completely different problem with a completely different solution set. So first, let's just talk a little bit about what and or mean. So I think it's easy to think back to set theory. So and versus or. So and is another word for intersection. Do you remember what intersection means? The symbol for intersection is like an upside down U. And typically, when you've probably seen this in the past, you were looking at things like Venn diagrams, where these circles are representing two different sets. The intersection is the overlap. The elements that are in both set A and set B. So that shaded area where the two sets overlap represent the intersection, which would be A and B. Likewise, or means union. The symbol for or is a U. So if we were looking at a similar Venn diagram, sets A and B, the union represents elements that are in set A or set B. So the element just has to be in one of the two sets to be in the union, A or B. So again, that's everything. So if we apply that logic to our inequality statements to find the solution set, we want to go ahead and just solve each inequality as you normally would. So add 2, divide by 2, so x is less than or equal to 4. And is part of the problem, so don't neglect to write it. 3x is greater than negative 9, so x is greater than negative 3. Remember, when you're solving a linear inequality as these, the only thing you need to remember is that if you multiply or divide both sides by a negative number, you want to switch the direction of that inequality sign. We didn't do that here, so we're all good to go. So this is basically the solution set, but you want to write it in a condensed way. I always suggest graphing the solution set, whether you're asked to or not. So on the number line, I need to plot negative 3 and 4. Okay, so we want numbers smaller than or equal to 4, so that would be including. So I'll do a closed circle, and then I would shade to the left for smaller than. And then we want strictly greater than negative 3, so that would be an open circle, and then we would shade to the right. So my interval notation, or my answer in interval notation, since I'm looking at an and statement, would just be the overlap. So the elements that are in both of this set and this set. So it would be, the overlap would be here. So it would be from 3 to 4. I would not include 3, so that would be the round parenthesis because 3 is not in both sets. But I would include 4 because of the closed circle. 4 is in both sets. So the interval notation representation of my solution is this. So now if I want to look at this as an or statement, so looking at this example right here, again, I would solve it exactly the same way in terms of the algebra, except I'm looking at or. So or x is greater than -3. So again, I would draw the number line the same way. I would plot the same two important points, -3 and 4. Again, we're looking at, so x is, I dropped my or equal to, x is less than or equal to 4, so that's a closed circle and a shade to the left. And again, strictly greater than 3, so that would be an open circle and a shade to the right. So this time, I'm looking at an or statement or the union. So that's everything, all numbers that are in one set or the other. So in this case, my interval notation solution would be all real numbers from -infinity to +infinity.